It's the Packet Thrower! Welcome to the channel! In this video, we're going to play around with Hyper Converged Infrastructure by deploying a Nutanix platform. And this will help us introduce some of the concepts and see what all the fuss is about. So traditionally, we would have something like this for a virtualization environment. We would have a few hosts, and then for them to have shared storage, we would have a SAN down here. And then we would typically have a fiber channel connection so that we have dedicated storage. And then the SAN would be something like EMC or NetApp, whatever the actual storage provider is. Doesn't really matter for this scenario. And then to actually get to our network, we would have a switch here and we would have uplinks up here. The idea in the old environment was that the storage was isolated from the network, and the network was its own thing. And what this did is we had the fiber channel environment, which was maintained by its own switches, and then we had the network environment, which was maintained by its own there. So you had to provide two different environments there for your environment, which got costly and was getting pretty unpopular. So then with the invention of things like iSCSI and FCOE, we started to put the SAN on the network instead, so it didn't have its own segment. And then we would just have our switch network, and everything would be connected to there, and then it would be up to the switch to make sure that the storage has the proper isolation. The idea behind hyper-converged infrastructure is rather than having different storage segments, what we do is we take advantage of the software-defined way the industry is going, and we add some disks into our hosts, and then what we do is we pool the storage virtually to create our storage that the cluster can use. Now there's a few different vendors here. So for example, VMware is vSAN. Nutanix is what we're talking about today. And Cisco has HyperFlex, which I'll probably make a video on pretty soon as well. So in Nutanix land, we have a layer called Acropolis. And what this does is provides a vendor agnostic layer that will provide the distributed storage fabric and the app mobility fabric. The distributed storage will handle the actual storage between all the hosts, what they call nodes. And app mobility provides things like the ability to move virtual machines across the cluster. I mentioned that Nutanix is vendor agnostic there, so we can run pretty much any hypervisor. We can run ESX, which is pretty much the most common one in the world right now. We can run Hyper-V, which is Microsoft's attempt, and Acropolis Hypervisor, or AHV. This is what we're going to be focusing on in the video, just for fun. And then I'll probably make a follow-up one where we talk about ESX. Not a huge fan of Hyper-V, so I probably won't bother with it, but we'll see. So this is the Nutanix support portal where we can download all the files we need, and we can see there's quite a few that they offer. So the main one that we care about is the AOS. This is the operating system that Acropolis will run on. So first, let's just get our network set up. I have two Nexus 9300s for this lab, and I just threw together a simple Ansible structure to get this going there. So if we look under roles, Nutanix tasks, I'm basically just setting up the interfaces, the VLANs, and the basic VPC, and then we'll have a look at the Nexus afterwards and finish up the configuration. So I'm just going to go ahead and run this. So now that Ansible's done its job, we can have a look. The first thing I'll point out is if you haven't used Cisco Nexus before, you do have to enable features where you can use them. The main one we care about is interface VLAN, which is how we create SVIs in Nexus, and also VPC, which we'll talk about. And this is going to bundle our Nexuses together so that we can have our port channels. So if we look, we can see we have a few SVIs created. And the main one we care about is 240, which is going to host our management stuff, specifically the Nutanix IP management interface. This provides out-of-band connectivity to the server nodes there, so I can connect to, and this will let us actually install the Nutanix operating system before there's actually an operating system. A lot of vendors actually have a similar solution there, but it's very important when you get into server administration. And 241 is going to be where our Nutanix hypervisors are installed to. So if we look at these, we can see that I have set up the IP addresses for us. I've also set up IP version 6 as well, and the reason why is the Nutanix Foundation installer uses IP version 6 to discover nodes, because it expects you to be plugging your laptop directly into the node when you do the actual installation. So this is just a trick to help it along. And then I have also set up VRRP so that we can have our two Nexus nodes working properly. And if we look here, I didn't point it out, but feature VRRP is enabled. So the first thing we want to do is set up the trunking between these two. So Ansible is taking care of the actual trunking, but for the VPC configuration, we need to configure what they call the peer link. So what I'm going to do is just say channel group, and we have a lot more options here than on the Cisco solution. So I'm just going to go ahead and say 1, and we're going to use LACP. And actually, apparently I missed LACP in my list here, so we're just going to say feature LACP. There we go. Let's try that again. And then under the port channel, we say that this is a VPC peer link. Though I'm getting a little bit ahead of myself apparently, so we have to create the domain first. And all we do here is tell it how to reach its peer for keep alives. So if we look at our configuration, our management is set up with 10.11.255.11, and the other guy is 12. While I'm here, I'm also just going to say feature LACP and VPC just in case it's not there. So what we'll do is we type peer keep alive destination. We tell it that IP address. We let it know that it's in the management VRF, which is a separate routing table. And then we can customize this a bit by saying that this is going to be a peer gateway because we're running VRRP. It just helps the configuration. And peer switch will present the two switches as the same root ID there so that spanning tree doesn't get confused. So with that in place, we can now go back over to port channel, and I can do my VPC peer link. Now we'll just do the same thing on the other side, and then we just do the opposite command there. So destination 10.11.255.11 VRF management. Oops. Switch and peer gateway. And PO1 VPC peer. Now with all that in place, we should be able to go show VPC, and we can see that everything's successful there. It is saying that type 2 consistency is failing because of an SVI. So what that probably means is that I have an SVI here that isn't on the other side. So just bear with me 1 second. So there we go, now it's all successful. If you're curious, I ran the VPC consistency parameters, and I was able to see that I had a mismatch between my SVIs, so I just cleaned that up. And we're ready to go. So next what we need to do is set up our port channels for Nutanix. So if we look here, we can see that I have my Nutanix nodes listed, and basically it's going to be one interface per switch. So if I look at these guys, we can see that right now they are just set up as access port. So what we're going to do for each of these guys is we are going to take out the access VLAN, and we're going to make it a trunk port. And we're also going to turn on edge mode. This is the same as port fast if you're used to the iOS Cisco. And then we're going to put this in the port channel. So we're going to say channel group 11 mode active. And I'm just going to do the same thing for the other guys here. Like so, except for this is going to be channel group 12 and 13 will be 13. So now I'm just going to grab these. And we could put the same thing on here. Then all I need to do is go port channel 11 is going to be VPC 11. 12 is going to be VPC 12. And 13 is going to be 13. So if I look at show VPC, we can see here because the Nutanix aren't configured, they're just going to be down for right now. But everything else looks good. So if you're curious what we did here, so we have our switch 1 and our switch 2. And then we set up a port channel between these. That will be our peer link. And then down here we have, let's just say, a single Nutanix box. And we are creating a port channel between both of them here using VPC. So that way, even though they're two switches, they act as one as far as the Nutanix is concerned. Neat stuff. So now with our network ready to go, the next thing to do is to actually log into the Nutanix. And what we can see here is it gives us some diagnostic information. But for our purposes, what we care about is the network configuration. So I'm going to go down here. And we can see that I've statically set an IP address to make my life easier. And as I mentioned earlier, I have set up IP version 6 so that it will help out with the Nutanix Foundation discovery. So here's the Nutanix installer, what Foundation gives us. I haven't actually deployed it as a CentOS virtual machine. But what you can do here is you can import configuration if you already configured that using the install site. We're not going to bother with that. It can also auto-detect its platforms. So you can see it supports everyone from Dell to its own gear to Cisco. We're just going to let it auto-detect. And then it gives us a bunch of options there, like do we want to support more advanced features like RDMA? And if we say yes, it's just going to let us know that, hey, this is only supported on certain hardware. Likewise, it's going to ask us what kind of port channel we're going to use. So we say none if it's not going to configure. Static if it's if you say you have a standard license for VMware. And we're just going to use dynamic there, and it's just going to let you know that, hey, Anacropolis supports this, but ESX, you're going to have to manually do it. And likewise, Hyper-V is also supported for the wizard. So based on what I said, we're going to use 241 for our hypervisor subnet. And then it's going to want the net mask, so I'm just going to go ahead and tell it a /24. And then the gateway is going to be 241.1. And then it wants to know the IP address of the IPMI interface because it's going to assume it's not configured by default, but it's going to fill it in anyway. So we're just going to go ahead and say 11.240.1. So then it's going to let us know what type of networking is in place here for the installer. So if you're going through a routed network, just let it know, and then you have to enter in more information. But if it's a layer 2 network, then it's going to rely on that discovery. So I'm going to go ahead and hit next and see what happens here. And you can see IP version 6 broadcast failed, and also there is no broadcast in IP version 6, so you can tell Nutanix isn't quite fully focused on networking. So I'm just going to go ahead and manually add these, and we're going to say this is going to be 1 block and 3 nodes per block. A block is basically just a bunch of nodes together for a single administrative purpose. We'll let it know that I have configured with IP addresses and go add. Okay, so I filled in all the info. Basically, it wants the IPMI IP addresses. It's going to want to know what host IP that we're going to use, and also the IP addresses for the, and also it's going to want the IP address for the controller VM. Because basically what happens is that it will spin up a virtual machine on each of the hosts there, and then it will use that to create the Anacropolis layer. So with that in place, we're going to hit next. So we can choose to skip the automatic creation. That's no fun. So I'm going to go ahead and give it a name. We're just going to call this TestLab Cluster 01. It wants to know the time zone. We'll just say and that's my time zone. We don't need to get too much into the storage stuff there, but it's going to ask us how much mirroring and stuff. We're just going to leave this at default. And we're going to get this cluster virtual IP of 241.200. So for NTP, we're just going to point this to the local server. And we'll also give it pool.ntp.org. And for DNS, it's going to be 10.11.200.11. We're just going to leave all this stuff as default, so we'll hit next. And it's going to want us to pick the AOS that we downloaded. So I've already took the liberty of uploading it here, so I'm just going to hit next. Now it wants to know what hypervisor to use, so we're just going to go ahead and pick AHV. And we're just going to use the one bundled in the installer. Next, it needs to actually log into the Nutanix, so we're going to give it the credentials for the IPMA and go start. So this is going to take quite a bit of time, but what we can do is I will pull up the web console here, and what we'll see is that eventually this is going to reboot and start doing its installation. So this time the server is booting there. You can see that the installer is working its way through its process. If we check the log, we can see the stuff it's running through. Basically, it's doing some validations, it's mounting the install media, and now it's booting off the install media into what they call Phoenix, which is their installation platform. So this will take a bit of time to actually complete the installation. So I will pause things here and we'll pick it up when it's done.